Should probably update my chat title. Let's, I don't know why, but I just find the Twitch UI to be impossible to understand. Channel. So if I'm streaming now. Oh. If I'm streaming now, how do I change my stream title? Create a dashboard for me. Probably should have done this 5 minutes ago, but that's okay. Edit your next. Oh. Next stream info. Wait, is that gonna apply to this one? Let's find out. Implementing a plunge in the next. Brain exploding emoji. Let me put this on screen so you can see. Behind. Cool. But I don't think that this is actually going to apply. Oh. Stream info updated. Okay, cool. And I don't want to see myself like that. Software and game development is for Rust. Oh no, that's the game. Whatever. We're good. We're good. Cool. Okay. So what I'm going to be attempting to do today, this is like the second Rust program I will have ever written. I did a little FizzBuzz this morning to get the tools set up. Today I'm going to implement. Let's go to Befunge. Befunge is this cool like little 2D stack-based programming language. So you take basically like this grid of a program, and there's a pointer which starts in the top left corner, and it steps through. But when it hits one of these special operators, it actually changes direction, which is pretty cool. So the program is like it can read this in reverse, step through there. Cool. Okay, so I think if I go cargo new befunge, there. Nope. Open up code window. Cool. So I've got an empty Rust project with a main and some Rust tooling. I'm assuming that I should be able to run this at some point. Oh, it's still booting. Here we go. All right, so definitely want this to be at the bottom. Cool. Hello world. My second Rust program ever. So I think the first thing to do would be we got to write the interpreter. So I'm going to grab this hello world here. And I'm just going to create, I guess like hello world dot. Yeah, sure. Cool. Stick that here. So the first step is going to be, I guess we're going to want this in an array. It's been a long time since I've thought about anything that's memory managed, so it's going to take me a little while to get up to speed. And when I say memory managed, I mean a language where you have to manage the memory yourself. Cool. So probably a good place to start is just like reading in a file in Rust. Hey, so we got a standard FS. Where did this come from? Oh, cool. We can just read the string. That's pretty easy. Cool. So if we go that program fs read to string, nice, and then should be able to just do. Oh, my goodness. These little annotations are quite distracting when you're trying to type, but I'm sure I'll get used to that pretty quick. So this will just be /hello world.bf. And I'm just now realizing that that is also probably the brainfuck extension, but we won't. I'll keep it for BEFUNGE. And then it looks like we should just be able to do print line. Just give it an empty format string, and then I think we just give it a reference. Oh no, we can just go program. Cool. Now, it's not implemented. Oh, okay. I missed the expectable. So it's currently returning a result. So this is a way to pull out of that monad and just be like, give me the value or throw a panic. Failed to read the file. And oops. Cool. Okay. Let's run this. All right, we've got our program. So I guess the first thing to do would be to read this into 2D array or 2D vector, and I'm not sure whether I want it to be ragged or, and when I say ragged, I mean like you have this kind of like array of arrays, and there'd be like different symbols. So like in this case, it'd be like, and then a whole bunch of like nothings, a whole bunch of spaces, and then, but on the next line, if it's ragged, this can just have, you know, one operator, and if there's no other actual text there, it can just be shorter. Interesting in what way? Oh, also, I should probably at some point get an extension to put the chat. Why don't we just put it over here for now? There. Yeah, oh, okay. So the entire goal of this language is to make it resistant to compilers. But not interpreters. I'm not writing a BEFUNGE compiler. I'm writing a BEFUNGE interpreter. Yeah, the whole point was to create a language that could only be interpreted and not compiled. But interpreting it is actually very straightforward. I just don't know Rust at all. So, oh, right. That's going to be annoying. Maybe I'll just... We don't need a whole... No, come on. That'll do. Oh, it's under. Cool. Just line it up with my image there. Okay, so I guess first thing, I'll read it in, and I want to What is the time? So this will just have a whole bunch of new lines in it. What if I want to read the lines? Rust, read lines. If let okay lines. Oh my. That's an interesting syntax. Where does this come from? Oh, right. I'm just not used to seeing implementations below. The output is resulted, routed results. Oh, okay. So you can open a buffer and you get an iterator. And I assume this. Okay, does this take a file? File. That's interesting. Cool. So let's do that. Can you do like constants in Rust? Like constant at like the sort of namespace or module level? Hmm. Oh yeah, cool. I guess this is a declaration. Oh. Ah. Uh-huh. Oh, that's fine. We'll just use the cool. And if I want to pass this in, can I just pass that in? Or do I need to? Okay. Alright, so let's go. Oops. It's not a new function. Oh, that's interesting. Uh, what is the difference? So, at star is a sort of reference to. Wait, can I? Yes, take me. Is this one just stored on? Wait, is this one just stored on the heap, or one of them? Here we go. A Rust string is like standard string. It owns the memory. It does the dirty job of managing memory. Rust. Oh, like char star. Uh. Okay. Cool. Uh. Excuse me one moment. I'm just gonna open the door. It's very hot in here. As soon as I start streaming, my computer just turns into a space heater, which is very frustrating. Okay, in static storage, string literal food, and static string, data is hard coded. It's a heap allocated string. Oh, okay. So this. Hmm. Read lines. Lines shows an iterator of the lines of files. Okay. Uh, I don't know if I need IO results, IO lines. Oh my. A file surrounded by a buffer reader surrounded by lines. Surrounded by a result. That is it. What is IO lines? As a time. Oh, so this is struct lines. Generic type. Iterator over the lines is instead of buffer reader. Okay. That's interesting. So we have a file, and there's like a. I'm assuming this is like a file handle, and there's a buffered reader that is pointing to that, and then there's lines which knows how to iterate the lines of this, and then that whole lot can fail. So I guess we wrap it up into a result, but we just coerce it to okay. Like, where does the error handling actually happen? Huh. So there's path. Standard IO, thank you. And file comes from there. Oh, that's interesting. I like the way that you can nest these things so you don't have to repeat std over and over. Is there a question mark? Oh, oh yeah, there is. Is this too small? I can like bump up the text size. Oh, no, that's very large. For me, maybe not. Yeah. Okay, so what do you do as an operator? Result file error, and that's the result error. Okay. Cool. So how does this just become file? Rest question mark operator. Recoverable errors. Results. Da, da, da. Question mark is error propagation. Using question mark operator. Does that mean that this scope will just return error if this throws an error? Like if this file name did not exist. Oh, okay, that's interesting. F# has a formalism of that. Yeah, I know this returns a result, but I just don't. I didn't understand how this machinery works. It's very like it's not very explicit how like the error propagates out. I'm assuming if you called a bunch of these with a bunch of these question marks, they'd all have to return the same error OK type, right? As in like the type of result would have to be the same if you wanted to use this like 3 times on 3 different things within the one function. For the sake of just learning a little bit, I'm gonna go match. Okay, so we can take an expression here, and this will be open a file name. Then we go with Mr. Oh, it's just complaining that I haven't done an exhaustive match there. Okay, so I think I'll just go okay. I'm assuming this will be file. Yeah, cool. We do an arrow, and I'm gonna go okay, and then we're gonna construct the IO. I actually like doing these things inside, so we'll be like file.lines. Oh, we're getting the lines of the buffer reader. Okay, so IO buffer reader new, and then we'll go file dot lines. Cool, and then if it's an error of E, we're just going to go error of E. Oh, error like that. Can I return these? Oh. Wait, I think that's it. Okay, except for this. Recoverable errors. Yeah, okay, die inside the okay. Can be used, and I'm assuming that they all have to return the same time. Return result or option. Yeah, that's cool. Okay, so they have this. Right, so these are computation expressions. It uses from on the error type returned. But if there were 2 different error types, if you called the question mark operator twice, wouldn't that make the return type of the function ambiguous? Okay. Why are we not happy here? It's for the ideal result in the function definition. So I know that. But I'm saying like the you specify the only results. Wait, so can this result, the error can be anything? Because if I did, so if this returned, for instance, if this returned like error 2 or 1 or whatever, Surely that should complain. Yeah, I know. So what I'm saying is like, yeah, okay. So you can only call the question mark on, like in this scope here, you could only call, in this function here, you could only call the question mark operator for things that returned IO error. Yeah. Not sure I like that syntax, but I do see how it would save time. It just seems kind of like it's explicit because you already have a return type, I guess. Um, okay, in any case, I'd like to return okay IO buff reader new file dot lines. Save. New method name lines. This method is available for buff reader file here. Yeah, sure. That makes sense. Oh, okay. We just need this without the first bit. Oops. Fork that. Relax. Path. What have I done? Cool. Sweet. So now this gives us results. And can I do? Is this an expression? Oh, why can't I type? What is going on? Oh, so I could just go. Aha. File should exist. We'll be lazy. And then we can go do. That should work. Aha. Which really means that I probably could have put the expect on this call and then chained and then wrapped the rest, but that's alright. I'm happy with this. Okay, so line equal line. Oh my god. Yeah, I know. Shortcut expect is pull out the OK value and then panic with this message if it's not there. The reason I'm still matching here is because we need to wrap this construction because you have to put the expect. I guess you could go like the expect. Thing here. Yeah, that. But that's alright. I don't mind. Yeah, I guess this is like something went wrong already. File. You know, let's be one step less lazy. IO results of that or IO. Oops. Hang on. T. Takes one generic argument. Oh. Why? Oh, right, because it's the IO result, not just the regular one. Gotcha. So this basically has that other, this type parameter has been applied somehow. Yeah. Cool. So if we go read lines, file name, then we'll do out.expect. One thing I've been enjoying about writing Rust is that the tooling is really fast. Like these messages and dot completion is ridiculously quick. I'm a big fan of that. So we get lines as a buffered reader file, and that gives us some sort of iterable thing at the top. Something like... Can you supply like a function to this? Because I basically want to like get the error value in here. If I put, because I'd want to be like actual error. Expect include error. Not sure if that actually does. Does it give you the message and tell you what went wrong, or does it just give you the message? Can set message, custom message for the panics. Oh, okay, it looks like it gives you some context, so we don't need that. Reading the source. Cool. We don't need this anymore. So if we dot so we have this lines type. All right, close. This. And programming in a new language that's very different from anything I've done in the past always makes me feel very stupid for the first few hours. Oh, okay, right. So if something has an iterator, you can just plug it straight into a for. That's kind of cool. So let's just try that initially. But I'd really like to map this into, we're going to create a pausing step. If let okay, I don't know why they call this IP, but in a paragraph maybe, or whatever. Yeah, I saw that just before stream. I was looking up how to like print arbitrary data structures. Lines derives debug, so you can use this syntax. But I suspect in that case, would it just give me a bunch of methods, like, because it hasn't been iterated yet? Let's just see. Print line. Oh. Question mark. Lines. Let's see what we get. And we'll do that as well. Yeah. So this is what I expected to see. It would just give us like its properties. Because it's an iterator. Or yeah. Cool. But we did get this. So if I want to map lines, vector from iterator Rust. So I just want to slurp lines. Oh, lines has a map. Cool. Dot map. Oh, great. Now does this take a lambda? I don't know how to it takes a lambda and creates an iterator which calls closure in each element. Transforms one iterator into another. Great. So this will still not be realized until we read it, but we can do some of the processing beforehand. Okay, let's do Rust closure. What does that look like? I should just do like Rust vect.map. Really? Okay. So if we want to go inline, like this? Wow. Ah. Huh. Interesting that that is a result. I'd actually like to do list sequence. Yeah, sequence? No. What is the sequence in Rust? For context, what a list sequence does is if you have if you have, let's see, you have results, okay, error list like this, it transforms it into a results okay like this. Oh, which is really what I'd like to do first. So if you know what that function is called. Dot map dot collect. No. From iterated implementation result for this. Okay, so it looks like we can do collect. Results of what was the OK case of map here? As a result of okay, so we actually just want a result of string vector, basically. Result vec string for error. And this result is probably this. So they're mapping into, we're already in this, we don't have to do this mapping because it's already in each element of this iterator is a result. Oh, can you work it out? Error underscore goes. Oh. Oh, okay. That's why. Okay, now I've got a result of vector strings, and now we can do dot expect to pull out single line unwrap. I don't know why that would happen, but which means we don't have to do that. We can just go let like this, and then what? Irrefutable if flat pattern. This pattern will always match. Oh. Replace. Okay. And then. Oh, what? Okay, whatever. Well, line, string, and lines. I don't think we need to do this at all now. We should just be able to go print line. Not too many. Okay, let's see. We get what we want. Cool. Okay. So that's handy. So we just wanted that part. Cool. This is when it gets realized. Is it? Oh no, we're realizing it with collect. Cool. So we actually just have our vector strings. I think it might be time to start implementing the parsing. So I want something that will take an individual character and output basically like a list of enums. We want to this is going to be interesting because I'd like to have enums that have data. Rust enum. Okay, so we're going to have our like enum operators. And then there'll be like, I really want like digit of like I32, something like that. I don't know if Rust enums can actually have data like that. Oh, okay. We just need to set it off like this. Just digit of I32, or okay, bishop abstraction into logical not. What do we need in our hello worlds? Not much. Well, we'll do the maths. And we'll put the explanation here too. It's tabs. I'm not feeling good with my typing today. That's okay. Commas. Oh, great. Oh, okay. Yeah, that makes sense. Yeah, I guess it wouldn't actually pause the line until you realize it, so that's all good. Okay, we know hello world. We need the star operator, which is multiplication, and we need comma and the at symbol. At symbol is probably pretty important. That represents the end of the program. End program. I'll just put end. And then I don't think we need a modular yet. We will need to implement right, left, up, down. So let's do like data definitions, mathematics, control flow, which in this case is changing which direction we're evaluating from. Huh. Right, left, up, and down. Cool. I like that the formatter automatically aligns those. That's pretty nice. I wonder if it just does that on enums or in general. Start moving in a random direction. Ooh, that's scary. Okay, I think that's it. We're also gonna need string literals. Start string mode. So control flow, mathematics, data definitions. I guess these are operators. And this would be like I'll just call it string mode. Because when the program first encounters one of these, the string mode will begin, and all of the subsequent characters until we hit another one of these will be included in our string. They'll just be read as characters. String mode. So maybe this should be like toggle string mode, and then yeah, okay. Don't think we're using much else. Got our end. What does the comma do? Pop value output as, oh, okay, so we can print from our stack with pop. So I'm gonna put that here. So this is the start interpreting program data as a string one start/stop. Cool, and then this pop last value from the stack to console. I guess that's cool. Oh, it just snaps it. Great. Let's go with that for now. Might not even need this. And I don't think any of these will need data. I know I've called this operators, but this is really like symbols. Yeah, because these are kind of like operators that return the because these aren't the actual digits 0 to 9. The way I was thinking of this is like you're pushing digits to the stack. It's actually a function. Like if you see 0, it means like push 0 on something. It's not just the data 0. It has a little bit more of a connotation there. It would be interesting if there was another mode where it started reading a number, like a longer number. But I don't think this language does that, so that's cool. I don't know if this is worth. It's not actually I32. It's just 0 to 9. Is there a type that represents digit? I think trying to encode that into the type system is just a rabbit hole. We would just do some error handling goodness. Okay, so let's just do get. Oh, a U8. It's probably that's still too many values. I'll just leave it as an I32. We'll want to constrain it programmatically and not just in the type system, like because it needs to be validated that it's not larger than 9, for example. Well, it can never be larger than 9 because we're just processing a single character at a time, so it might not even be an issue. Maybe to signify that this is supposed to be tiny. We'll just go to U8. Cool. So these, I guess like these are actually like kind of data pushes or data constructors. I don't know. Cool. All right. So that is the. Oops. Right, so most programs will always start with one of these control flow things. I don't know if there's like a default, but every little program that I've seen always starts with the right character. So if you're in the absence of that, I don't actually know what you're supposed to be doing. But I guess you always just read the first one. Cool, so we're going to need some evaluator state. I'm getting ahead of myself. Okay. So what's the heart of the interpreter? We're just gonna do a little like design spec document thing here. What does the interpreter do plus these? We'll pull this out to a function. Fun read program. And I'm still getting used to the syntax here. I think this just takes a okay, so it's like generic and then file name string. Maybe this needs to be a reference string to I've been writing too much JavaScript. Single arrows. Vector string. And it's going to go in there. I'm just going to return that expression. Yeah. Back. Okay. So let's go. Program equal read program. Sure. I think this is going to complain. This is an and no. I just type this as and Yeah, easy. So I think if we read this in, it would be a string, but we're not going to do that at the moment, so that's fine. So we've got our program as a vector of strings. So the first step is, I guess we're going to do a pause each line. Actually, we want to run this. We actually don't want to transform it all into a program. Well, I suppose we could, yeah. Let's go, like, so the first thing would be like the pause phase. That involves read in program. Convert all characters into either operators or some symbolic representation. And then the run phase, we can expand this step through the program. calculate state at each step, maintaining stack direction of the spool. Yeah, this state here will be the state of the stack. So it's either doing that or perform side effects for stateful operations. Well, I guess there's a bunch of side effects, but perform external side effects like printing. Cool. So let's tackle this one. We're gonna read the program and convert all the characters into operators. Because we currently have a vector string. So what I actually want is a vector of operators like this. So we have our operators. Now, I suppose I could just define a function that took a char and outputs an operator. Let's do that. How do I... So we have this type operators. How do I extend the type? So like these functions here that are like, this is, or types that are in this. Is this a namespace or... Impl operator, open call. Okay. Because I want to use this operators as a module too, so I think. And then I'm guessing that functions that go in here will be accessible by like operator. So we really want like operator pause or something like that. Impl rust. Okay, so we can just define fun pause. This will take C, which is a char. I'm assuming char is fine. Character type. And that returns an operator and operators. Yeah, which is a poor name. We're gonna fix that. Operator. What are you telling me? Change visibility to public. App derived for once. Well, debug maybe. Sure. You do impl from. Would that be, would I call that like from, would that be like this? Okay. I think this is what I want. Oh. Traits from T. Okay, and then the for operator open close that constrains T to operator, I think. Okay, yeah, let's try that. Impl from for T. And then do I just put the function inside? Lowercase, okay. Okay, so this will be our C, char, and this gives us operator. Are we not happy? Associated function input without body. Oh, is that just like if I just returned right, is that gonna uncomplain? No, the char type. Error. Self. Oh, to self, right. And this becomes operator, okay. And I actually want like, yeah, no, you know what, we'll just panic. So we'll just go match C, and then we need this. If I just did A to, well, okay, we'll do addition. So plus to addition, operator addition. Well, haven't quite worked out why they use one error in one case. Unknown. Let's add that. That's a bit of a smell, but unknown. Oh, cool. Good. Let's hope so. Okay, so I guess you're gonna need parentheses when you. Ah, cool. Okay. So. God, that's terrible. Zero dot dot. Oh, that's cool. How do I alias this as a variable though? So if I go 0 dot dot equal 9, because I want digit operator digit, but I want this to be the parsed version of this character. Is there like an as? Oh right, yeah, of course. We still got C in scope, and we know what it is now. Parse char to number. Rust. Dun, 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 dun. Oh, I think we can just go. Parse. U8. Dot. Expect. I just need to. Oh right, that's the broken version. C dot 2 digit. Ah. Digit. What is theoretics? Oh, 10. Is that the base? guessing that returns an option, but I want to just get the sum value. This is the least safe code. As you ate. We just do this. C.2-digit unwrap. Okay, so we're gonna coerce it here. Cool. So we have the digits. It's really nice. Go plus. All right, let's implement the rest of these real quick. My goodness, this integer. I actually want that to be called integer divide. Oh, it's not divide. There's no floats here. Cool. So don't need all of these comments anymore. And it's all going to return. Oops. Total. Huh. Vision. So minus asterisk slash string mode pop is column right, left. All right, V, and the rest are unknown. Cool. There we go. Oh, and we need our N. All right, so we got pop. Total string mode, digits. That. Cool. Oops. All right. Now, we should be able to convert all the characters in our program to this. So we've got operator. Now we actually want to go... Okay, so I think if we... I'm going to call this pause program. Pause program. Expect. Then we're going to go map. This will be line. Why unknown? It's a vector strings at that point. Can we not map a vector? Rust. Map in standard iter. Dot into iterable again. You got map a line. What we actually want to do is call Line, does this have a map? No. Into getter. Okay, I actually want to go from string. Is there a way to get access to the underlying as starts into chars to map. Oh my god. C, that's a spelling operator. And we're going to go, good lord, operator from? Oh, maybe I can just give that as the C as operator. Okay, but can I do this? No. Okay, you can't just give it a function. Construct map standard vector. Oh my god. Okay. Expected struct vex string. Oh, right. We're just not. Any? How do I just get it to infer? I just not type it? No. I just want the result of their expression here. Yeah, see, because it's actually not coming out as that. We're expecting a. So this into chars. We have to collect the map back up into a vec. Oh, so this map function. Yeah, okay. Collect. I think we should just be able to go. Wait, there's a vec collect, isn't there? Where do we do that? Now read. Where's our read program? Oh wait, we already did it up yet. Collect. Back. I'm not doing this correctly. Good iterator. Why can't we call collect on that? Okay. Yeah, so we can just give it, because of the traits, gotcha. So this, we can just give it the type here, vec operator. Nice. And then what are we not happy about here? It's just because we, as, consider using the from trait, operator, what? Okay, just need it to be lower. Wait, no. Oh, okay. I'll just have to be, yeah, I'll just call that. From C. That's fine. Oh, no, not C. Operator. Cool. The value vec operator cannot be built from iterative elements type map chars. Oh god. We need a body. No, no, we don't. Doesn't this just item equals operator in our iterator? How do we get here? We just call it. So we've got an into a string. So this is a string. Oh, right, we need to do an inner collect. Aha. This is it. Yeah, because we actually do want a vector of vectors of operations. Vec of operator. Collect. Well, this inner one might be a vec. Vec of operator. Oh, what am I doing? I need to put this outside the map. Vec of vec. Yeah, yeah. Cool. That's pretty gnarly. I wonder if there's a way to simplify this. I feel like you should be able to go from a string. How do you map the chars in a string? Is there a I don't need as oh yeah. Well, that's something. I don't want to use. No, I don't want fold. That's not definitely not right. I suppose it's not too bad, considering there's some like error handling in here as well. It could definitely be one of those. Try and move into iter. Oh, on chars. This might be an iterable already. Yeah, cool. There we go. And then this vec here. Do we need the iter on there too? Yes. That's okay. And then dot collect. Cool. Cannot find the function. Yes, this is actually a pause program. Cool. And then we just want to print line a program. Debug derived. This might be a little long, but let's see what happens. Right, unknown, unknown. Oh, what is space? Because we should actually just have. I'm assuming it's just a no-op, because that would be it. Space? No-op, yeah, okay. Instead of operation, from here, maybe under. I'm gonna put under data. Operator. No, operation. No. With a. Okay. Digit no op. Alright, let's run our program again. Cool. Right, no, down. Is there a way to pretty print? Pretty print back. Rust. Let's see. Fly macro. No, that's not the one. 2D back. Rust. Okay, that's alright. Maybe we'll for line in program. Let's do this instead. I'll compare it. Toggle string mode left. Yep, okay, cool. That looks alright. What else is coming up as unknown here? Toggle string mode. Oh, right. Huh. Converting the program like this might not be the smartest way to do this. Because when we hit the string, everything, even if they are operators, everything past that needs to just be interpreted as data. I think that's okay for now. We can keep most of our parsing logic. There is a stack, yeah. But the thing is, like, if you hit a string, even if there's a comma or an asterisk in here, it needs not be multiplication or pop or whatever. It needs to be the data equivalent. So like the thing that parses this, well, the thing that interprets this actually needs to go step by step, continuously. Because how we parse the data is state dependent. Yeah, because if we're in string reading mode, every character we consume will be pushed onto the stack as string data. So that's okay. I think this parse program is ill-conceived, but I think our operators are still okay. We actually need something like we literally need like character or ASCII. Character of jar. And oh no, we're not now. Yeah. That's what I'm saying. So basically, like, what we want is a reduction over this 2D array, but we can't use reduce because the direction can change. But, well, actually, we need to do a reduction, but it's like kind of a little bit more complicated because the state is the program. Okay, let's design our like parser state now, I think. Yeah, cool. So we know we can gut this. We know we can read in characters. This from will need to become stateful. This read function will need to become stateful. We can't just implement this from char. We need to implement like a read function, and that takes the state of the parser at a certain time. So Which makes me think like I think maybe we should leave the program in chars as a 2D array of chars, uh, and only ever convert the next thing. Yeah, okay, let's do that. So we need to define like a struct, I guess. So like struct parse state, and in here we'll have like a direction, and that's going to be a direction enum direction up, down, left, right, and then we're going to have oh cool, thank you. Yeah, I saw that on the Wikipedia as well. We can try that one in a bit. So if I just create a new file, hello world.2.pf. Thank you for that, Tolkien. Yeah, so we're gonna have a direction. You need to know our like coordinates. So this will be like an x. Yeah, we do row. I32. Call I32. Because yeah. Then what are the things that can toggle our reader's state? I think it just for our like subset of operators, I think it's just the quote mark. So I think this would be like reader mode. Reader mode. Reader mode. And this is going to be normal or string. Cool. So to interpret a program, all we really need to do is implement a function. This is going to be like a reduction, and it takes a program and an initial state, and then basically performs a reduction. The program doesn't change yet. So what's extra interesting about this language is that you can if you implement the P character, the program can change itself. It can change its code while it's running. It does a little bit of metaprogramming with these P and G operators. So I'm trying to design this in a way that's going to make that not too difficult. I think thinking about it as a reduction is definitely the way to go. So I'm actually going to need this a moment. More screen real estate. So I'm actually going to write we need a function that takes an operator and does something to the state. Oh, I'm forgetting the stack here as well. Stack, and then I actually want a stack. First. Standard collections. You can probably use a vector like a stack. You want a stack. Okay, is there like a push pop? Stack. Yeah, okay, sure. This is a stack back of that's interesting. What kind of data gets written to the stack? Let's see. Close, close, close. I think it's always numbers or ASCII characters. So just char. We'll just make it a char for now. Don't have to make it too complicated. We can different operators will have to coerce, especially if it like takes the top two, adds them together. Uh, you'll get a runtime error if one of those things isn't a number, for instance. So it might be worth it at some point to convert this to like numbers and ASCII. To yeah, let's uh, yeah, I was thinking that, but like you could represent the stack data with a type as well. So you could represent it more explicitly. Child always fit inside a U32 example. But if we make it a vector of enums, we could do like enum stack data, and this can be digit of you know, we'll go B16 or char ASCII, and then this could be stack data. And that way we can do pattern matching on we can pull the top two things off and do pattern matching, and if they don't match the correct type for that operator, we can just do it there. We never even have to do like checks. It's just encoded. Does that make sense, or is this going to be a real pain? uh I'm tempted to call this stackable, but making checks at every level to make sure ASCII is digit. What do you mean ASCII is digit? This would be excluding the digits. Because if you read 0 in string mode, it should be the character 0, not the actual number 0. Um, not quite sure what you mean here. Um, the stack could potentially have a large number. So the stack data, we probably actually do want to do like this actually does need to be I32, yeah, because there's a subtract. Maybe even like a bigger, but I don't think we'll run into that at this point. But I think sure, I64 works. I64. I think at this point, specifically delineating when we were talking about the character 0 and the number 0 when you push on is going to save us some pain. Cool. So we need a few functions. First, the one I'm avoiding writing is the thing that takes an operator and a parser state and outputs a new parser state. Because this is basically our like folder or reducing function. I also need a function to you know what, we'll put the program in here as well. This is a back of string. A different bit of code running when we're inputting. Yeah, but okay, I see what you're saying, but we actually want to modify. We want to modify this from so that it takes state, or at least reader mode. we should be able to pass this, and then we can do a match on reader mode. And then if reader mode is in normal, we can do this one. And if reader mode is in string, it will just like so we can just do a 2-level nested match here, matching on the reader mode, and then specific implementation for each mode. Because we still want to end up with operators. Like when we read a string, that will, I guess yeah, we've got a character operator, which actually means like push character. So I might actually rename these to push digit, push character. Oops. Cool. Got all our types. When we read a string, we're just realistically reading next value as ASCII digit until we hit. Yeah, I know. But we can specify the entire parser as a reducer. We're basically just going to do one fold where we pass it a function and it just folds over the entire program, and we should be able to look at the state at every point in its execution. Okay, let's re-implement our impl from, and this is just going to be oh my god. It's just going to become a regular function. Something like, so instead of this, fun get operator, and that's going to take state, no, just a reader mode. Reader mode, and reader mode, and char. Char. Cool. Get operator. And we're just complaining. Oh. Then we don't need. Okay, right. Oops. Whoa. Huh? Oh yeah, we need to return type. It's gonna be an operator. Yeah, push digit. No up. So we need to get a match. I don't know which impl it would belong in though. I don't know if this code belongs to the operator type because it's dependent on reader mode as well, and reader mode is an operator. The concept of an operator is not conceptually linked to how our parser works. It just exists in isolation. And if we make this in an impl, this function now becomes stateful and context aware of like how we're reading. That's why I don't think it belongs as a operator like module function. Good suggestion though. Honestly, like thinking about stuff like that is my favorite part of software development. Yeah, so I think we should just be able to go match reader mode, and then if we are in, what do we call this? If we're in normal mode, we should be able to go like just do this expression. Cool. And if we are in string mode, did I call it string mode? String mode, string. Then we'll do match C again. Actually, no, we just return, no matter what C is. Oh, we need to check for the closing, um, or the end of the line, actually. What happens? Does it wrap? Or if you go out of bounds, I think it's an error if you go out of bounds. Because looking at all of these, they specify you have to start moving downward at the end of every line. Um, okay, so that's cool to know. It's even simpler. We don't have to like wrap around to the next thing. So yeah, if we're in string mode, match C. If it's this, we do operator dot string toggle string mode. Oh. Otherwise, it's just oops, I meant to say not like that at all. If we get that, we toggle the string mode back. Can I just do this? How did I do it over here? Oh, why did that work over there, I should say. This expression has type char. Underscore. And we're just going to go push character C. Cool. So that's our get operator, and I think those are the only two things. So now this thing is in isolation. We give it the reader mode in the next character. Doesn't matter what direction we're moving in. Cool. Now we need a function that takes. Okay. So we can either implement the parser, but I think first we need to do the meaty one, which is fun update program state. Oh, I just realized the Rust seems to do this same case thing. Update program state. So this is going to take a program state, so a parser state. This is actually not parser state. This is interpreter state. Okay, so we got a state, interpreter state, and an operator. So operator to a new interpreter state. Oh, I suppose like we got mode. We need something to track like when we're done. We're done. As in like we need to be like program is over somehow. Might just put a terminated boolean for now. Cool. Terminated. Now, can I do this? No, that's the coercion thingy. Right, so we're not doing that yet. I don't know if it would be actually, because then like you have the inverse. Uh, the reason I don't think this is an impl interpreter state is because that wouldn't tie this to operator. It's kind of the inverse of before. You could make it generic over like the operator set, because like what we're kind of defining is we're kind of defining a 2D interpreter, and it doesn't really matter what the operators are conceptually from our conception of an interpreter. Like this has no mention of operators, just how to move around, just how to move around a 2D interpreted program with these things, but like you could use a whole bunch of different operator sets. Uh, I don't know if there's a way to do like an impl for like both these specific types. um, uh, instead of you can have a non-impl type, a non-type impl. What do you mean? I don't know what that is. I'm also just if we want to go down the type rabbit hole a little bit more, impl interpreter state, open close. Okay, just thinking about this terminated issue for a sec, because we're doing this like reduction, we actually kind of need to define an iterator for this, or some kind of yeah, because we're going to end up needing a function that calls our evaluate over and over and over until, oh yeah, I guess that's fine. We'll just leave terminated there. What would this impl interpreter state give us? Like, what is there? Because like just to have it in the module, or like I'm still not super grokking Rust's state.update operator. Oh yeah, potentially. Uh, I yeah, I don't. This isn't going to return a mutated version of this. It's going to return like a whole new one. So this should actually be like derive new state. Derive state. Given an interpreter state and an operator, give us the new state, or the next state. I'm going to try it like this for now. Boo. Boo. Cool, so we got a derived state. So interpreter state, we will take an operator in interpreter state, and then we will do the meet. Okay, so we're actually gonna get match. Update program state self. Okay, I still don't think tying this operator makes sense to tie it to the interpreter state. Like I don't think this operator belongs. Those impl blocks, are they like modules? I don't understand enough about how the Rust organization works. Match operator, not with. Okay, let's get our operators. While I'm thinking about that, I might also Google input blocks, but I'm going to let's implement the changes first. And by changes, I mean, yeah, cool. I'm going to work out if this is the right thing to do or not after we implement this function. Cool, so just delete all these. Cool. Huh. Okay. How do I pattern match out? I think we can. Oh, is it smart enough to know that if it's push digit, then state. Oh, I'm gonna have to work out how to. Okay, just gonna put an escape hatch here so it doesn't yell at me. Just gonna check state. Which is probably. Oh yeah, fat arrow expected here. I just go state. Does that work? Okay. Why? Comma dot question mark. Oh, did I cut off? Some indentation stuff here. Yes. Okay. Yeah, we do one at a time. Push digit. So this is going to be like state with push the thing onto the stack. So I don't know how to return a new copy of something. Oops. Rust update record of structs. This is going to be. I'm assuming there's some update syntax because I'd like to just be like everything else plus. Oh god, hello. Struct date syntax. Oh, you can spread. Nice. So, right. That's great. So it could be like stack. I think that's what we called it. Stack is. Oh, so one thing we can do, this stack data equal stack data. I do want to do this from no, what was our expect the enum found char. Oh, I don't know how it worked that, but where's our other from? Where we did the. Oh, I pulled it out. Okay. Oh, whatever. From operator. What's up the from? Okay. We need self, so I'd like to go import from operator for stack data. Fun from operator goes to self. Cool. I'm gonna go match. Not with, nope, not with, just like that. And if it's push character, we're going to go ASCII up like that. And if it's operator push digit, we're going to go digit up. Right, and this will probably need to be as I-64. No. Stack data. Otherwise, panic. You can't push that. Okay, so our push character expected unit struct. Oh, any. Can I define that? Oh, awesome. That's awesome. D. And then we'll go D as I-64. Ah! This operation cannot push to the stack. Cool. Great. So then in our derived state, stack, let's be state.stack dot push, and that'll be this push digit here. The D. Oh. Oh, I don't need to do this. That's a shame. Hate that. Alright, this is just digit D as I-64. Dot state. Now, probably messed up. Struct literal body without path. Struct literal inside the block. Oh, do I need a two dots? What? Too much JavaScript. Do I need this? Cool. Push digit. Wait, why can I push digit U8? Push character char. Why can I access it there? Oh, right. Huh. Stack.state.push. And I'm expecting that. Is there a version of push that returns a new stack? Push back new stack new back. Oh, maybe I just need to do something like. I wonder if you can spread a vector. So I could probably go back from comma, dot dot, state dot stack. No, you cannot spread the vector into an array. Range to vec stack data. Man, these traits are wild. E as 64. Okay, because I really want to. This is what I want. I just want to get a new vector with D on the head of the vector. Maybe trying to do too much immutability is hard in Rust, or I might not be understanding how this is possible. What is stack here? Oh, right. We actually want digits. Okay, how do I push onto the front of a vector and get a new vector? Push head, Rust. I am no. New vector from vec Rust. I want a pen but get a new vector. What does extend give us? Oops. Temper state Rust stack is state dot stack dot extend. Extends a collection with the contents of an iterator. So look at me. Look at me. Update value. Yeah, no, I understood the API you're going for here. I don't know if derived state belongs to the interpreter state, because if anything, there should be a type called an interpreter. Ooh. There should be a type called an interpreter that has two type parameters, and it takes an interpreter state and an operator. And then you could derive from both of those. You could derive the implementation for derived state based off two type parameters. Yeah, I don't really know. That's more. Don't really know how to achieve that though. Okay. So extend is not what we want. Is there a duplicate or a copy? So this doesn't. How can I change the fields of elements? Wait, that's. No, I want immutable. Is there an update? Is something I can give a function to? Oh, what's up? I'm stuck. Still trying something straightforward. Is there no answer to this? Am I just like, it's just really against what Rust is for. Get new vec from vec. How do I? Oh, wait, I could do vec from uh state.stack dot push. Smash types. Vec of stack data. No. Push digit d as I64. Performs conversion. The push modifies its receiver in place. Yeah. That's kind of what I want. Digit. Oh, wait. Oh, damn it. Hmm. Continuous curl blurry time. How do you copy one? Let's see. Constructs a new in. Oh. Uh, Rust copy back. Uh-huh. Stack dot back. Fun cat. Let's join. Contiguous growable array type. I miss my persistent data structures from closure. I just did. Stacked up push 1, 2, 3. Let's push. Depends on element at the back. Oh yeah. Because I really want to do state.stack.push. Can this be like a whole thing in itself? Like, let new equals state.stack.toBack. Trait bound stack data clone is not satisfied. Trait clone is not implemented for stack data. Trait clone is not implemented for whatever. Derive copy. That should be fine. That's pretty cool. Derive copy. Common copy, common debug. Sure. Dot push. New vector dot push. Digit t as I64. Why? Oh, instead of this, it's stack and dot state. Okay. How do I? Oh yeah. Well, that's kind of annoying. I don't know if you're still there talking, but if you know like a nicer way to express this, that would be amazing. Particularly this. All right. Operator. Push character. Ah, that's okay. Learning, journey together. C. Ah, I really like the that nested pattern managing. I bet you could even put pattern expressions in here, like nice. A static memory address that gets passed around between each struct. Now we have different versions of ideal here. Is I want to be able to look at all of the stacks, like all of the intermediate states of the program as it's running. Um, and the way that this is efficient in functional languages is they implement something called persistent data structures. But I think for this interpreter, I would rather the expressiveness of or having all the states over the speed of updating one in place. Because I would write this very differently if we were just looping, because it'd be like a while. I'm trying to do this a bit of like functional Rust, I guess. um, it's cool. It's really cool that you can match in here. I'm glad that they let you do arbitrary, and I bet if this was an enum, you could like do any level of nesting you want, which is pretty sweet. So we're gonna do basically the same thing. State does stack. Oh. Isn't this the same? Or do you mean you could go state.stack.clone dot push? Because this is what I want to achieve here. This duplicates. This creates a new copy. Yeah, push. Oh, could I just go two back? Oh, right. Yeah, it doesn't return itself. That's the issue I've been coding around. Because, like, stack. Yeah. Stack dot. Well, we can replace this with clone. Uh, oh yeah, DT. There we go. Okay. This is exactly the same, except this is C, and it's going to be ASCII. Vertical version required. Cool. All right, operator. Okay, let's start doing the Oh, that's cool. Just create a scope. I don't think. Yeah, does this have to be mute? Yeah, I would rather do this though. Yeah, I like. That's cool that you can create a scope in there, and then do new stuff. Uh, yeah. Cool. And right, we can't do that. Yeah, they're about the same. I do like that though. Then we don't have to actually Oops, I did it. Okay, let's do addition. Actually, what are we using? We're using multiplication. Addition. Right, so this is a stack operation. So we're going to go let value. How do I? X equals up. Y. Now I know this isn't going to work, but I'm just writing this out to obviously that's not a mutable stack. Lay. I want the back to let mute s data equal state dot stack dot clone. This is trash. And then s match. Okay, so we want x comma y. I don't know if I need the see mashup. Yeah, no shoot. Okay. We want some digit. Here we go. D. Twice. Some stack data digit D. I'm going to call this A. And we're going to output. We'll do a thing where we go s dot push A plus B. We're not happy why. Oh, data. X is an option of digit I64. No, X is an option of stack data. What? No field stack on. Oh, data.pop. Okay. There we go. Option of stack data. Missing some brackets there. Cool. Sweet. Data. Data. Why isn't it liking that? Stack data. Use the tuple variant. I am. Am I missing? Oh. Okay. Some A B. Do I need no space here? Is that important? Return data. Actually. Oh. Does this need brackets? I have a whole lot. This. Smashed closing. Some stack data digit B, I64. Yes, fix my K. And okay, so we did need that, and it's just not updating. Aha! Push digits A plus B. Um, Oh, right. Stack data. Digit. Then we want to return data. That's right. We haven't got an exhaustive match. If we get anything else here, I actually want OK. Like this. Oh, no. Some. Oh, you know what? We'll just return data. So I might need to make a helper function which takes our stack. Fun mathematics, mathematical ration, and we have a stack. Just put data, or stack, whatever. And this is our stack data, and we have an operation, which is a, now I don't know how to type functions. Type function order Rust. Should just be able to type this as I64 to I64 to, which is clearly not. Okay. Which this isn't. How do I take a function? F. No. Oh, just like lambda? No, no, no. Probably a little out of my depth at the moment. Yes, take a function as a parameter. F. Oh, you can just, I guess all of this, it's usually F. This is some to back stack data. And then, oh, but before that, where F is a fun from I64 to, but I might have to do this. Okay, Now here we're gonna do our this bit. We're gonna get our like operands. DT. And then I'm gonna grab our internal match bit here as well. And I don't think I want to do error handling. I think I'm ready to use panic at this point. Match opx offline, because we can only do a mathematical operation if we have numbers. So if we got two stack data digits in the stack, then we can get our data, turn the data. I think yeah, we'll do that. So I think that's fine. Otherwise, anything else, panic. I think we can put format. Nice. Cool. So this will be tempted to add that. This will be x y. So we'll either need, well, that way we'll know. Expected function found macro. Panic louder. Format? Format argument must be a string literal. Is it not? Yeah, that should work. It returns, creates a string using interpolation of runtime expressions. I think we need to do that. Examples. Hello. I want to do this. Am I not? Maybe just do this. Format argument must be string literal. Literal format. How is this different from that one? Don't really know. Oh. Missing a string literal. Oh, well, that's good to know. Still angry though. Match arm body without braces. Oh. Cool. All right, and now we should be able to do. So this will either return us. This just gives us a new stack with the operation applied. Now we should be able to just go interpret state stack is, yeah, we'll just get a new one. So this is our mathematical operation state.stack. This one is, I'm hoping I can just give it plus. Oh. Expression, expect the expression found plus. Yeah. Is there a plus? Oh well. X, Y. X plus Y. All right, cool. So that simplifies a lot. We can go operator addition, operator subtraction, operator multiplication, and division. And we just need to go minus, asterisk, divide. That's integer division, that's okay. Cool. Oh god. Alright. I like how it says it tells you which match arm is missing, but it doesn't like give you a prompt for what you should put there. One of the coolest things about matching in F# is it gives you an example of a pattern that you've missed. It's quite cool and very useful. But maybe it does that if I try and build it on the command line, like build. No. No, it does not. That's okay. Alright, so we can soldier on subguts. Let's go toggle string mode and pop, sure. Operator. We haven't encoded side effects in a way that is nice. So what we should actually also add in our interpreter state is done those. What we should actually add in our interpreter state is like a standard output. And this is a back of whatever. Doesn't need to be complicated. Because then we can write the output. We don't actually have to do any side effects at all. We can just view that value. Otherwise, we have this like pure function here, but we'd have to do like a print line, and that does not make sense. Okay, so we've got pop. Let's do toggle string mode first. So I should just be able to go dot state. Does it work this way around? String reader mode. Probably not. Reader mode equals you can do match like that. Match state dot no dot reader mode state dot mode. If we're in string mode, reader mode string. If we're in string mode, we'll go to normal. Otherwise, if we're in reader mode normal, go to string. And I know this is like kind of roundabout. Now why isn't that up? I think we might just need a comma. Oops. Struct literal body without path. Does that work? Oh, maybe I just need. Maybe then putting this. Come on. Should be expression, right? I want to set the reader mode to this value of the match. No such fields. What? It's right there. Ow. Oh, shit. It should just be mode. Nice. Okay. Operator dot pop. Not dot. More than pop. Interpretation state stack is going to be yeah, actually this is going to need to be an expression itself. Let's outval equal state dot outval equal data dot pop, and let's. So I think that's all we need. Let output equal data state dot output dot plane. Yeah, this actually can be in fact stack data as well. Forgive me, for I have sinned. Uh-oh. Oh yeah, I mean that's fine. You just call this like a mutable stack or something. Where you overwrite push and pop. Can you make this generic? Also, you could probably do this with traits. Just find a new struct that wraps back. Isn't there a way to implement these new functions with traits though? So I basically just want to add a function called like an extension method called like pop self.0.clone. Only if the library defined them. No, but you can add your own traits like Rust extension methods. Extension traits in Rust. So we go like impl t stack. No. Spec t. Actually, no, I don't know enough about it. You can definitely define extensions to any type you want. It's not just if the libraries define them. You can do whatever you want with traits, and they're scoped, which is quite nice. So you can import that particular trait in the scope. Watched a really good talk the other day called API design with this one here. It's definitely oh my god. You can't add a custom function to an external struct. Disagree, because he did it for iterator. Yeah. Oh, I think he created a new struct. Did we? Yeah, I'll go towards the end. Yeah, you can do this thing where like you implement extensions for your type, but you like it because you can implement the interface. I guess this is a little different because you're implementing the iterable interface here and then extending that interface. I don't know. I'm just gonna keep going. Keep doing the keep doing the slow way for now. You have to create your own type and then do a lot of glue. I actually don't think it is much effort. I just don't know how to do it. Yeah. Just make a push rat. Yeah, okay. Fun push. Oh no, because I want to do multiple pops most of the time. Pop rats. V T T. Oops. Okay, no worries. Thanks for hanging out and for helping. It's very helpful. Thank you. I'm confident I can get this running in another hour or so. I'll catch you later. T. No, this is going to be T. It's going to be the most inefficient. T. Let data equal v.climb. V.climb. V.pop. That should be satisfied now. Oops. Oh, let data. V.0.line. I think playing is just struck. Oh, oh, can I just do? Cool. There we go. So if we just want to get the last thing off the stack, foul is data open, so stack pop ret stack dot output. Separate state hash derive line copy debug. It's this. We'll also need and probably this. Okay. Copy debug. Which field does not implement? 107. Oh yeah. Yes, it does. I'm pretty sure they all do. Find copy debug, find copy debug. Okay. Let's delete these. Tempted to operate over to do math with cool. So data. I don't actually need that. output data. Put return t e t to new vec t, where t implements clone. Let t will be the clone. E dot push e. D. Huh. Okay. Disgusting performance hacks. I'm really abusing this language and writing some pretty non-idiomatic code here. Potentially. It's all a learning exercise. So output data, we just want. Actually, now we might actually be able to just go into operator state. So stack equals state dot stack. Oh no, we need the out val. Okay. Operator state equals oh, that was. We need the modified stack though, so we're gonna have to still do state stack. Let's create new stack. New pop. Let out. Okay, so I think that's what we need to do, and then we should be able to go stack is equal to new stack. Output is equal to put return. Let's see, use state dot output, and then this would be out val. Expect no value to pop. Oh wait. Really going off the deep end here. So group together. What haven't we implemented yet? Oh yes, the directions. Might move direction above our operator, because instead of right, we're going to change this to change direction, or set direction. Set direction. This is going to be direction. Cool. Then here, instead of all of these, this is going to be operator. Grab those. Oops. Set direction. Cool. Right, left, up, down. That way, when we come to set the direction in here, operator. Yeah, and I probably should have implemented some of these functions where I'm manipulating the interpretation state. Interpreter state could probably be on the interpreter, like but we're just doing them all in line for now. I think it's okay. So we get a set direction. All we're gonna do, directoin. All we're gonna do is turn an interpreter state with the direction as direction dot state. Nice. Cool. I compressed 4 to 1. Now we've got end and unknown. Operator. Let's do no operator. Oh, and in every single one of these branches, we need to update the position. But we'll do that after. Okay, that's all good. We can do that in a separate step. It's a very cross-cutting thing. So this operator no op. It's just interpretation. Let's just go state. Operation end, and this is an interpretation state, interpreter state, with terminated true and the rest. Now, what are we missing? I think no op or push digit, push character, the maths, pop, toggle, set direction, no op, end. Unknown. Operator unknown. Panic. We didn't know what to do here. Sure. I might just, if anyone's watching, I'm just going to stretch my legs for a few minutes and I'll be back. I have returned. Refreshed. Okay, I'm gonna also check that anytime I've used panic, we do with this. Excellent. We've only got 3, that's pretty good. Although we have a few expects as well. So I might actually have to do let partial update. What's that? Just return partial update there, so it's happy. Damn, it's a big function. This is angry. Oh. Oh, okay. Now we want to calculate a new position. So I'm actually going to implement a function on direction. To give us back a, okay. Struct move is just row u8 16. Yeah, whatever. Cool. 32. We don't need that. Direction. Simple. Get move. Takes it. Output to move. Okay, match D with. Not with just braces. Match D up. We go to move row 0. Column -1. Up, right, down, left. Okay, so if we go right, the row. Oh no, this is, yeah, -1 row. Column stays the same. If we're going right, the column increments by 1. If we're going down, the row increments by 1. If we're going left, the column increments. Cool. What are you playing with? Oh yeah. Cool. Now in here we should be able to go const, no, let move equals get move. Oh, direction. Oh, does that mean we can go state? No, partial update dot direction. Or does that need to be? Where is that directions? Oh, no. So that's how you do traits. Does that change it? Should update that direction. No, okay. All good. Let move. Oh, it's the same thing. Let's. Partial update that direction. Okay, just call. That. So we're going to turn our interpreter state, and now the row is going to equal to state.row move.row, and the call is going to equal state.call plus move.call dot state. Ah, all right, now we've moved. Now we need a function to actually get the next operator. Cool, so that's done. This is a real mess. Temper state does not need to be. Could be here, really. If anyone's watching and they have any questions about like what I'm doing, or if you just joined in, feel free to chat to me. Let me know. We're currently writing an interpreter for BEFUNGE. I don't know if anyone is there or has tuned in recently. It's a 2D stack-based language, and we're going to process a little program like this where the caret can move around and change direction. It's very cool. Okay. Get operator. Just going to return an operator, or it's going to panic because this is going to have a program. I'm just going to be a vector of string. That's our program, I think. Yeah, vex string and a reader mode. Nice. Operator. All this is going to do. Oh, the program. Let's just call this a position. I can make it more generic. A point struct. Program position. Cool. It's going to take a program position. Position vertical. Oh, you can do destructuring. We're going to just return operator and try and placate. Now, the name get operator. Oh, should actually be like to regular. Actually, this should be pause operator. This one is a bit higher level. It's actually getting an operator at a particular position in the program. The program, which is a vector of strings. Could not find type string in this scope. How is that possible? At all. Struct with a similar name exists. String. Oh, I just didn't save. Of course. Okay, so we're gonna attempt. So program. Let line equal program dot get. I think this just takes a position. Returns an option, which is good. Row. Dot expect row out bounds. Okay. Index is an I. Slice index. Find dot. We just type string cannot be indexed by. Wait, program. I'm not indexing string by 32. I'm indexing the vector. As index. Index dot from. Huh. I really do just want to get a slice. Rust vec get index. Nope. Oh. It's program dot ida dot position. Wait, does this have? Okay. And wait, what? No. Index. Does this work? Oh, no. Why does that work? U size. Oh. Let operator equal, let's see, line dot as chars. Call as size. What's chars? No, find. I do want to just oh. First try index chars. So, indicator of the nth. That's U size. Option char. Oh, does this have nth? Okay. Dot expect invalid column. Cool. Okay, so we have the operator. Now we can go pause operator, reader mode, operator. And that's what we're going to return. There we go. Got that. Now, how do we create an iterator in Rust? Iterators always have to point of convenience the for construct. Oh, you just keep. Oh, cool. Okay. We can implement an iterator for this. Simple iterator. Oh, sorry. Impl interpreter state. We're going to implement the trait iter for interpreter state. Next. Self to an option of self. I don't really understand why. Ah, we will need. How do we define an iterator that takes multiple options? Dropping its first n terms. First 4 terms of the Fibonacci sequence are. Okay. Okay. Because what I actually want is this next. We need to define an interpreter. How do you have an interface, so like a type? Oh, sorry. I didn't see your. What do I mean by multiple options? Okay. I need to create an iterator that takes the function to get the operand and the function to return the new state as parameters. And I'm realizing that I need some construct where I have like an interface-ish type thing, which is called like type, like my interpreter. And this is like interpreter state, comma, operator. And the function I want next needs to take self, which is the interpreter state, and a function from operator to a function from self state and function that takes self and an operator and returns an interpreter state, which is this here. Because at every point in time, we need to call this to get the operator. We need to call this to get the next state. But I don't know how to make like a more abstract type because it doesn't need. Like, I guess, how do you make generic structs? Like, because I basically want struct interpreter interpreter state, comma, process derive state operator. Because it doesn't make sense to keep the operator as, even though operator is a type parameter. Hello, Sam. So I got that part. Like, this will be like the inter state equals state. And I think I just want to leave the operator there hanging. As a type parameter. Let's see. How's your night going, Sam? Or day, or whatever, I don't know where you're from. Yeah, because I need to implement an iterator on this type. Which I probably can do. Iterators on generic types. Generic struct Rust. I don't know how to do the impl. This would be like, I want to specify the implementation. Maybe let's just give it a go. Implementation iterator for interpreter and this is going to be interpreter state, comma, operator. Tolkien, do you see what I mean? Like we have the abstract representation of what an interpreter is, and then we have a concrete implementation of our interpreter. Impl A trait for type A, yeah. It's I think fun. Lord, the side is white. Bright, searing my retinas. Iterator. This. I don't understand the purpose of item in this. Oh. You refer to this type using self item. Option of self item. So we change the type without having to update the. Oh. Not really. Sure. This will just be interpreter state. Operators never used. Yes, this is I am using this. Consider referring to it in a field or using a marker such as phantom data. I am using it as phantom type. Um, never used. Except in my implementation. Phantom data. Seems, yeah, phantom. I'm assuming phantom types are like compile time only, uh, basically like tags. Because I'm trying to tag this iterator, even though we don't need to know this type for what's in the struct. This iterator will have two type parameters. Because we want to iterate through the interpreter state with a certain set of operators. Defined up here. Because the operator state, the interpreter state is completely divorced from the operator state, or the operators, I should say. And there's a function that we've concretely defined to go from state and operator to a new state. So now I just basically want to create an iterator that keeps giving us new states until the program finishes in our interpreter. I don't think I need this. Next, need self component item. Self is a interpreter state op. Yeah, okay. Because I want to extend this to take a function. Next, eval f. Well, it should be derive, I guess. Derive. I think I need where derive is a function from state how do we do these wheres in the higher order? Goodness. Can't change the trait to find next. Yeah, okay. Ah. I guess we have to encode next operator. Okay, so maybe this is how we do it. So if it all needs to be in it all needs to be wrapped up in our interpreter. I have a state and a next operator. Okay, those. Let's next state equal. Okay, so I'm gonna put this. Oops. I'm gonna put the interpreter there, but I'm gonna put the specific implementation here below these two. So self interpreter state operator. Great. let I'll go back to the iterators. Sure. Let new self equal. Oh, okay. Let's get the let new state equal derive state with our self.state and self.next operator. Cool. If new state, let's do match. Match use. Oh no, what is if? It's a boolean. If new state dot terminated, we're going to return none. Else let next operator equal get operator. It's going to be a state.program. No, sorry, self.program. Oh, okay. Self.state.program. And I'm going to construct a let new position program position row equals self. You know what I should have done? I should have made the interpreter state position not row call. I should have made it that type, but we can refactor that later. Program position row self dot hello state dot row all equals self dot state dot all. And we are not happy. Oh, it's colons in record syntax or construction syntax. Cool. So that'll be this get operator. Oh, yeah, we take program, a program position. So I guess you could call this like, we'll just call it position. And takes a reader mode. Which will be self.state.reader mode. So mode. Wait to go sum. Oh, is this none here? I think we'll just do that, right? If oh cool, those. Otherwise, some derive state self.state next operator. Next operator. Oh. No, we've already got the new state. We've got the next operator. So I think we just need to return some interpreter state, new state. Next operator equals next operator. State equals new state. Oh, this is just this interpreter. Oh yeah, we don't need that. Okay. What have we done wrong? This item is an interpreter. Is it not? Oh my goodness. uh, Crap. What's gonna happen if I Okay, I need to go back to my pause program, and I'm gonna get rid of this bit. So we just want vex string. Cool. Where else we got issues? Use of moved value. Value has moved here. Value used here after move. Move occurs because state has type interpreter state, which does not implement the copy trait. Okay. Copy. Uh, 181, 182, 183. Oh. Spec does not implement copy. How do I... This means... Ah, okay. Shit. To be iterable, does your state have to be... What's this function here? Right, we're giving a new interpreter state. To do this... I'm gonna have to just do... dot state. So let's just do those vectors. So the stack equals state dot. Wait, we're on partial update. Does that work? No. Okay. Stack. It's gonna be partial update. Dot stack dot clone. And the output is going to be partial update dot stack dot clone as well. Just one more. Oh, the program as well, sure. This is probably the world's slowest interpreter. Oh yeah, that should be output. There. The base struct must always be... Ah. Update. Cool. All right. Cannot move out of index vex string. Move occurs because value has type string, which does not implement copy. Right. Line program. I want to be able to get the nth thing. dot to just do that. Does that work? No. Program dot. Oh, okay, cool. So expect valid line. Cool. And then, all right. Cannot move out of self.state, which is behind a mutable reference. Because self.state has interpreter state, which does not implement the copy trait. Move out of self.state. So we're constructing a new one. Does that just mean do I just need to like do I just need to pass a reference to this or something? What if this derived state took a reference to a state? A reference to an operator? No, that doesn't work. Update. You can only borrow it or make a clone. Oh, in terms of this? Can I invoke clone here? Oh, easy. And we can well, specifically on our operator here, derive clone. And clone. Huh. No. Oh yeah. That's fair. Go to the definition for this and rename it to next. Operator. Oh yeah. Probably done this a lot. Okay, they're definitely used. Let's go through all the new stuff. Not. Cool. And some more warnings. Oh yeah. I'm expecting this to just completely explode when I run it. This is never used. That's right. Don't need it. String. Oh, that is read mode. There we go. Good. Wait, do we never? Oh my god. Operation. Maybe. A can't be. There we go. Oh yeah. This is my first day writing Rust. um, but I've come from other functional languages where like generally, I know at least in F sharp, like we would tag the generics with a dash like this. Then you can give them like kind of more meaningful names. Although that doesn't work like that in this case. Thanks. It's been a painful 4 hours. God. Um, I don't know how long you've been tuned in, Sam, but do you know what I'm building right now? It's an interpreter for this language here called BEFUNGE. Yeah, it's like a 2D interpreter, and the kind of executing position can move, and like these arrows tell it which way to go through the matrix of instructions. It's pretty cool. All right, I'm terrified, but I might just I guess I have to create an interpreter. Let interpreter equals interpreter. Oh goodness. And hopefully it can just infer the generics, but the crap. I think I've done this the wrong way around. This might need to be an option. Because we won't have the next operator in the very first instance, but we will ongoing. Anyhow, state. Ooh, we should implement interpreter state fun 0, or I guess they just call this new, right? Rust impl new. Is there a trait for this, like for construction, or are they just normally functions? Fun new takes no parameters, returns an interpreter state, and we're going to just construct fun new self, and then in brackets. Oh yeah, I always forget that you can do this like self-referential thing. Self fraction. Right. whatever. Where's your call 0? The mode is going to be normal to start with. Stack is going to be back new. The program is going to be output all empty. Reload mode. And then terminated is going to be false. Cool. So we have this initial interpreter state. State equals interpreter state new. Cool. And next operator is going to be none. And it's not going to like that until I make this an option. Operator. And then in our iterator, this needs to be some operator. New state. This is kind of off by one problem because like the first thing we should be doing is getting the next instruction and then driving the new state for it. Maybe it doesn't even make sense to keep the instruction, put the sum in the let next operator. Otherwise you have to next operator sum. Let next operator. Oh yeah, I'm currently questioning if this is, I think I've done this the wrong way around because we should always get the operator first. Getting the next one is wrong. Let operator, and then this is going to be this whole deal. Okay, so I actually think yeah, not too happy with how I've written this entire function. I might give it a go. So we have fun next. We actually want to if self dot state dot terminated, and then yeah, we really don't need the this type parameter at all. But I do want to tag it with like an op type, which I know is, I kind of want some kind of phantom tagging thing. Phantom type, Rust. A phantom type error is one that doesn't show up as runtime. Yeah, but I do want to use it for determining the correct implementation. Phantom doesn't show up runtime. Static, check statically at compile time. These phantom tuples. Hidden parameter B. Oh, maybe I need like underscore. Can you put phantom data in a struct? Like underscore. And does this go away? Or does this have access to underscore x? Because I don't really want that. Whatever. Doesn't matter. Whatever. I will just work out how to do that type shenanigans later. So then this interpreter, for our specific interpreter state, that's fine. Self.state. Okay, so if not self.state, or is there a not function? No, let's bring this. Terminated. Okay. So we're going to get the next operation, derive the new state, and that will be it. Else, okay. So, next operator, that's what it's called, operator. Get operator, program state and self-define position, which we constructed here. Oh, okay. Formatting is cooked. So got that. Self.state.mode. This is oh yeah. And I think we're just angry because we haven't derived the state and returned it yet. I think since we're doing this, this will panic if it goes out of bounds. Equals. I think we can just go sum. If not, okay, why are we angry? Enum expected option, is that not? Missing a semicolon somewhere. There's one there, there's one there. Oh, I need to remove one? Oh, from here? Okay, cool. And then why is that? Expected struct interpreter. Oh, right. We need to. Okay, I will do. Let new interpreter. State equals that. Huh. And we don't actually care about this. That's not a thing anymore. Derived state. Oh, operator. Okay. Oh, actually, we want to do this, but this should take a program. That program. Wow, for state interpreter. Use of moved value program. Oh. Print line. It's gonna be messy. State. Huh. Oh yeah. Let's just stick that. Oh, wait, it does. It's right there. Excuse me? Oh, interpreter state does not. Yes, I suppose that's true. Hash. Derive. Debug. I'm pretty impressed that that works. Okay. Is this gonna just explode? Oh my god. Oh, it doesn't look like it's I think it's stuck. Also, we've got a lot more warnings in the command line. So let's go there. Create new terminal. Oh. Unreachable pattern. Up. Ah, that's probably why we're not moving. Okay. Unused imports. Does this work? Organize. Imports. No. Okay. Delete that. That. Oops. Is that correct? Oh, no, we need file. Alright, what have I done? Oh, it's an FS. Alright, that one. Slice index. Cool. Try it again. Can I compile? Huh. The buffer read. Alright. We've got all those. I'm still not anticipating it working. But I think we can definitely make a start on debugging. Whew. Okay, definitely it's not doing anything. The vertical is not moving. You know what? I'm gonna just whack like a Oh, hang on. Oh wait, terminated is false. Okay. I suspect we might be eating panics or something here. Interpreter.take. Let's do 5. Then we won't lose our minds. Boop. Okay, got our program. No output. Mode normal. Direction right. Row 0. Column 1. Where's our interpreter state? Where's the stack? We never put anything. The very first. Okay, if we set this to down. Oh no. The initial direction should probably. Does this take? This doesn't do anything with direction, does it? No. Okay. Right, but the position's updated based off the updated. So we always read the first character no matter what direction we're in, and the direction will be updated based off that character. So if I, we'll know something's happening if I set this to down, and yeah, oops, it's not what I meant to do. Okay, so the direction does get set to right. So we process the very first command. Then it should be no up, no up, no up, no up, no up, no up, no up. Do dot drop 5. Take the next 5. Oh, is that? Where do I modify the position? So I'll show you how we calculate the position. Oh my god, this file is a mess. My goodness. Get operator. Okay. We did get move on a direction, and this returns a. So if we're going up, this defines the move, and then in our actual derive state function, we take the partial update that we've calculated with these. Well, first we get the move, but we take the new direction, and then we apply that delta, like move, to the row and column of the interpreter state for the next iteration. Where's your column 1? Oh, maybe we're not doing the right thing for no op. No op just returns state. Huh. Is that going to be an issue? I might need to clone this. No, yeah, but regardless of applying the move, that gets done after. So we get the next move here, and then we apply it. So this doesn't change any of the other parts, but we still update that state there. Set change row to just +2 instead of this. question. Boop. We got to row 2, and then that's odd. I would have expected just 2, 4, 6, 8 crash. So interesting that the column is 1 there. It should be 0. What happens if you hit one of these expects? Looks like partial update row is always 0. That's so weird though, because partial update is... Okay, we're not seeing any of the panic messages, so I don't think it's going out of bounds or anything. As we saw, it was just iterating for ages. Partial update call is always 0. So weird, because we take our state and we construct a new state. And we're successfully changing the direction. Maybe there's something wrong with that iterator. Yeah, potentially derived state is always getting... okay. I think our iterated... We need the current and the next state, because we're actually just deriving the first state over and over and over. Okay, all good. I think... What? Oh no, it just returns... We're always returning the next value. Do we have to update the state? Self dot... I think we have to go like self dot state equals... Okay. Let new state equals this call. Oh my god. Is it in the clipboard? Nope. Let's see, I'm on my last brain cell. And then self.state equals new state. Cool. And I'm okay if that moves it, and then we can just return some self.state, I think. Expected. Oh, expected struct interpreter. Confused. Potentially, yeah. How does this updates itself and then returns? I think this should actually just be interpreter state. Because the thing we want to return is the... like this. Not all tree items implemented. Missing item next. Hey. Will we get the same value over and over? No, it actually panicked. Oh, plus twoing would have oh my goodness, it's starting to read. Okay, let me put that row. One, two, three, four, five. Direction right. Let me look at the let's look at this. No, we're doing this one currently. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's get the first 15 states and see if we're going down. Nope. Still going right. Interesting. No panics. Maybe we just need more. No counter them. Oh, it's pretty zero indexed. Direction down. Okay. Might go let state equal interpreter dot n. Let's get like 100th. Oh, that might be none because it can return nothing. Can we just go take until, like, take all? Ah, we're still 100. I think there's a pretty good chance that this may work. Or get close. Hey, it is terminated. Let's look at the output. ASCII HEOHELOWORLD. Oh. Oh yeah, I guess if we don't do take, it'll whew, terminated false. I think it works. What I'm gonna do, let states equals, is there a way to get all of the values of a sequence of an iterator? I basically want to do this because I just want to look at I don't want to be printing the program and everything every time. I guess I could just, I'm silly. Whew, state dot output. Let's do, let's make like a position row call row call output and stack probably. State dot row, state dot call, state dot output, state dot. Oh, it's all good. Huh. State dot stack. Interpreter lost. Oh yeah, cool. Oh yeah, I'll tell you what I wanted. I actually wanted. I didn't just want the one property. Uh, in fact stack data. Let's just try this. Because yeah, cool. Whoa. Oh. Let nice output equals state dot output dot map dot to vector iter So map. Oh, I might not need the 2vec. X match X. If it's an ASCII, stack data. No. C of C. I just want to have the string C. I want to basically unwrap this type. And if it's a we'll need to do .collect as well. If it's a and stack data digit D, just want to return D as chart. Oh, whatever, we'll go to strings. Is there string interpolation in Rust? Or do I just have to call format? Yeah, format, okay. C and format. Cargo format, cargo Clippy. Okay. I think it already is formatted. What does Clippy do? Oh, is it like the Clippy Microsoft dude that he's variable left? Cool. Oh yes. Good lord. Um, nice output. This should be consider giving a type. It does not know. Collect. No. How do I just get these values? Would have thought it would have been like that, but this should be a list of strings, if I'm not. Does this output a string, or is this the macro? No. I just want to take the inner bit and convert it to a string and have a list of strings that way. Oh. Oh. I see. We just needed a yeah. Okay. D end. Oh. Nice. Yay, that's pretty cool. Oh. Interesting that we get 10 on there. Oh yeah, I guess you have to like tag this. That's cool. That's cool. ASCII. I'll put nothing on the stack. All right, let's try the other one. This character here is a space. I think something's going on here. You didn't convert the insta ASCII. Oh yeah, D. Did you mean this one? Or oh, okay, cool. Yeah, I actually don't mind string formatting. It's interpolated strings have never seemed that much more ergonomic to me. They're just like it's kind of nice seeing the argument in place, but yeah, that is cool though. Um, hmm. Don't convert the insta ASCII. Maybe when I'm reading it, push character. It's just a char. What's the source for this? Hello. Oh, and then it does some stuff. World. But this is supposed to be a number, and this is a string. So I was expecting if we're getting these digits in here, that's a problem with the reading, not the writing. Uh, cool. I'm gonna run the other hello world. Let's see if that works. Oh my. Huh. Panicked at valid column. Well, that can't work. The very first instruction is go left. Uh, Telkin, you're giving me a you're giving me a dodgy hello world. I'll use this one instead. Ah. We panicked for what reason? Panic format, expect failed. Row 1, row 2, row 3, nothing on the stack. Oh, I think I grabbed space. Aha! Yeah, okay. There we go. Store 4 and 8 and multiply them. The output is 32. Ah. Ah, okay. This pop is always supposed to be as ASCII. Right. I see that they're constructing space. Ah, okay. Um, so our implementation of pop actually should not even respect the output, state that output. Since we're not using any other pops, our output should actually be a vector of just char. Put state.output out, stack data, yeah. And then I'm assuming, can we, I need to convert this as char. Oh, as U8. Some jank code to convert a digit to ASCII is X as U8. Ah, okay, and then as char. Nope, that doesn't work. This instruction to output is an integer. This out value. Oh, it's a stack data. Okay, we just need. Just going to take this, put in here, match out with. Oh no. Uh-huh. So this would be D as U8 as char. And that'll be char. This needs a comma. These are no longer references. Oh, we just want C. We don't want the format call anymore. C. U8 as instruction to output as an integer. The stack should really only ever hold ints and then output the int if. Yeah, you're probably right. I think you're right. Expect instruct. Oh, shit. We need to do the whole. So this should be let. Can you shadow in Rust? It's probably poor form, but looks like you can. Output is going to be state dot output dot. Wait, what did this look like before? Oh, it was a push ret. state.output dot out. Cool. What did I have here? Oh, put red. And it's perfectly angry because where did I come with that? For state is a cool. Let's try that. We don't need to do this nice output anymore. We'll just do state and output. Run that bad boy. Huh. Oh. We didn't know what to do here. Wait, why are we getting this again? Oh, this is the stack. Where's the output? Empty. Oh, we didn't even get to the bit. Ah, this one. Pop a value, move right if 0. Left otherwise. Huh. Damn, I don't have it. Don't currently have a. Oh no, okay, let's implement it. So this is pop, and this is going to be, what is the definition of that? Pop, move, right. Ah, we'll do pop, move. Nah, I'll just copy paste it, it's alright. Pop, move, right. Pop, move, left. Okay. So if we're in read mode, we're in normal mode, and we hit one operator, pop, move, right, and the vertical pipe character, operator, pop, move, left. Oh no, these are move up, move horizontal, up, move vertical. Cool. And then division, pop. Operator. My favorite direction is vertical. Vertical. Me too. Pop, move, vertical. Very cool. This will let me. It's basically this. Except need some helpers. I might implement on stack data. Jesus, wherever that is. Hang on, let me copy. Where's that pad matching? Oops. Seriously? Yes. I would also like sanely uh I would probably move the operator, like reading the operator and parsing the operator into one file. I would move the interpreter and the iteration into one file, and then I'd move the interpreter state and state derivation into one file, probably. What was I just doing? Um, oh yeah, implementing some helpers on our stack data. Implement. So this is a two. Fun s self two. Oops. Huh. Okay. Then here. Better yet, turn this into a lib and mark only the relevant code is public. Then make your main RS file use your crate as though it's an external library. Yeah, I mean that makes sense. I would definitely like massage the API surface. Like you shouldn't need. There's a lot of types that you shouldn't be exposed to. Like stack data is probably, as a consumer, kind of weird. Um, that being said, I mostly just picked this project to. I'm going to a Rust meetup tomorrow because the talk sounded interesting, but I'd never written Rust, so I was like, I can't go to the meetup and have never even like used the language. Two char. Oh, we just hit 5 hours. Did I implement that on a different type? Impulse stack data. Oh, getchar. Sure. Why match arms have incompatible types? In getchar? I don't think so. This just returns char. Oh, right. D, yeah. You can tell my brain is wearing out. The talk is Ashley. Brisbane. I think that's how you spell his name. Tips for building and maintaining real Rust code. This dude works at Datalust Seek. They're like probably the foremost company using Rust in Brisbane or Australia at least. Yeah, Ashley Mannix just seemed like interesting, and I'm kind of just stoked that like in-person meetups are back on. I've been looking for meetups to go to for 2 years, and they've all been online, which I don't really like as much because I'd rather just watch like YouTube talks at that point. Tips for building, maintaining real Rust code, exploring, building, organizing Rust code with a day-to-day use. Okay, so let out stack data get jar out. Just shadow that one. It's good. And then we can implement get int. Oh, it's just a copy paste basically. Oh, I didn't know that they. Is that a new thing, like on the Gold Coast? Uh, whatever, int u8 is fine in this case. I'll use, yeah, u8. Actually, it should be, we don't want to do a narrowing. So we'll just do an I64. C as I64. And this will just be D. Okay. So, pop, move, vertical. What are the rules? Getting started by 2 people per minute. Really nice dudes. Early to 2022. Oh, that's pretty cool. I'm hyped for you. Okay, so if the popped value is 0, we set the direction to right, otherwise we go left. Okay. New stack. Oh, you know what we're not doing? Oh no, we're calling pop unimmutable. Yeah, never mind. Okay, interpreter state, stack, new stack, output. Oh, no, we're not doing that. Direction. If out is left, out is 0. Does Rust have ternaries? Please. Oh, you can do an inline if simple like that. That's okay. As an expression. If out equals 0, then no. Left. Right. Yes. And we're not happy. Oh, right. There we go. Oh, this one should be horizontal. This is probably vertical. If now is 0, I think it's up. Otherwise down. Although, I'm just gonna check that. Down if 0, otherwise up. So no. Alright. Can we run this new hello world? We cannot. We didn't know what to do here. What else am I missing? The if only formats in one line if it's let equal. Oh, really? Ah. Vom. Yeah, okay. I added the actual like pausing characters for these, right? Underscore. Alright, what was our position and direction at the point in which we Row 0, column 19. Oh, we haven't even this is 21 and 19. What's that? Well, that should just toggle the mode, the string mode. Is it like this? Oh no. That's interesting. I'm missing right? What do you mean right? Where? It definitely moved right. Oh, colon. Oh, what does that do? Duplicate value on top of the stack. Okay, yeah, we'll need that one as well. That should be pretty easy. Whew. So these are the colon to operator duplicate comma and then operator list toggle string pop 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 duplicate. Then pattern match here. We need to do pop. Whack that there. What just happened? Why didn't you copy everything? There we go. Duplicate. New stack is clone. We're gonna pop it. And then I guess just call push 2 times. Don't judge me. Cool. Let's. Oh. What did I break? Oh, just need a comma. Oh yeah. Get new stack done. Just do that once. New stack dot push. Oh yeah. Oh, I see what I've done here. State.stack.clone. New stack.push. Last doesn't remove it, does it? No. Okay. Last.expect. Enum stack data. Oh, how do I like dereference this? Because last returns a optional ref thingy. Hmm. Panicked at nothing to duplicate. Oh, we got to the end, basically. Here. I'm assuming we're on row 1, column 18. Yeah. Hello world. The stack is empty. There's only 10 there. Oh, we print the new line. This goes down. Oh, maybe these are off by 1. That seems more likely. Hey! Oh, but we never got any output. So maybe not. Let me grab this from Wikipedia again. Can you even convert the output into a string? Yeah, I totally could. Hello world, row 1, column 18. Direction. What direction are we going? Yeah, is this program broken? Unless I yeah, there's a good chance that I've like cooked this interpreter in some subtle way. Whew. So if we go x equals sleep the last dot expect. Oops. And then dot collect. Take anything iterable and turn it into a collection. I think we want fold this time. Fold, initial value, empty string. We just get plus. Is there any way to give an operator? Like char.concat. Oh yeah. Nice. Sure, many a bug has been caused by that. How do I fold a list of characters into one string? So like A, S, should be char. Oh, okay, into iter collect. Oh, I'm also not even grabbing the output. The last unwrapped output. Hey, excellent, cool. From UTF-8. Yeah, that makes sense. Okay, well, thanks for hanging out. Really thankful for your tips, both Tolkien and Sam. Saved me a few times there. Um, my brain's about to run out of my ears, so I'm gonna call it there. I hope you guys have a lovely evening. Maybe I'll see you around here sometime.